Good morning. This is today topic is velocity, finding a velocities for a mechanism for a slider crank mechanism. In this slider crank mechanism that we have to find velocities. So, how we have to frame a slider mechanism by using a given data. Here the data, the connecting rod length and the crank length and constant speed. So, here in a single slider crank mechanism, the crank rotates with a constant speed, that is a 300 rpm. So, crank length is 150 mm and the connecting rod is 600 mm they are given, and the crank angle is 45 degrees. This is what they are given. So, here if you see the connecting rod is 600 mm, that we have to convert into centimeters, but because we have to draw on a sheet on paper by using a drafter or a scale. So, I am converting into centimeters. This is 60 centimeters, right, and here it is 15 centimeter. So, here 15 centimeter length of the crank and 60 centimeter length of the connecting rod, but these 60 centimeter we are not unable to draw in a sheet. So, that is why I have to take a scale for space diagram. Here a space diagram, I am trying to get a one diagram mechanism, okay, by using this given data. So, that I am taking here, it is a 15 centimeters is 1 by 2, that means 7.5 centimeters, and here it is a 60, then I can take 30, because I am taking a scale of 1:2 for space diagram, okay. So, these are the dimensions for this diagram. So, here we have a one is fixed link. One is fixed link. You see it here that I am taking here, it is a fixed one. So, that I am taking a scale of 1:2. So, crank length it becomes 7.5 centimeters and the angle is 45 degrees. Okay. So, I am giving a name for this. So, OP and connecting rod. So, connecting rod it is a 60 centimeters, that I am taking a scale of 1:2. So, it gets 30 centimeters. Here I am taking a 30 centimeters, then I am taking it on this. Somewhere I am getting a arc on it here. So, I can take a cylinder. So, at here is a piston. Okay. So, this is 30. So, the name of this is A. So, this is a slider crank mechanism. This is a slider and this is a crank. While crank rotates in clockwise direction with omega, that is the angular velocity. So, angular velocity is omega in a clockwise direction and the speed is 300 rpm. So, from this we can find out the velocities. So, velocity of B with respect to O, velocity of B with respect to O. So, we can denote like this, velocity of B with respect to O. The basic formula for velocity, linear velocity into, here it is the angular velocity is a radius, this is the linear velocity, we call it as linear velocity. While crank is rotating, there we have an angular velocity. So, we know the angular velocity, but we have to find a linear velocity by using this formula, that the formula is R omega. So, radius, here the radius is length of the link, length of the crank. So, here it is, while it is rotating like this, isn't it? So, this become a radius, okay. So, here R becomes BO, so omega becomes omega BO. So, how to find omega? For that we have omega is equal to 2 pi n by 60. See this, n number of revolutions per minute. So, we are converted to seconds, that is what we have to get it here, the formula 60. So, we will substitute and we get a value 31.42 radian per second. Okay, so units for angular velocity is radian per second. Okay, so we will substitute it here. BO, if you see that BO is the length of a crank, length of the crank. So length of the crank, if you see it here 150 mm, that means 15 centimeter, but we have to convert into meters because here the velocity, the units are meter per second. So that's why I have to convert into meter, 0.15 meter. Okay, so I am substituting here 0.15 into 31.42. So we will get 4.173 meter per second. This is what about the velocity of B with respect to O. So this is how to find with the use of a formula that we can get the velocity of B with respect to O. Okay, that is the magnitude. So what about the direction, right? So the direction, it must be perpendicular to the, this is the velocity of V with respect to O is perpendicular to, we have a crank name OB. So this is must be perpendicular to the, that means velocity always acts a particular link. Because, and why I am taking this direction, why not in a downwards? Because it is rotating in a clockwise direction, so the velocity is in this direction, right? So that is the direction and this is the magnitude. Okay, so let me come to the velocity diagram. How to get a velocity diagram by this data, right? Where we are dealing with a graphical method to find out the velocities in a mechanism by using a graphical method. So that's why we are getting. So this is a fixed link. So O is a fixed. Somewhere I am taking here it is a O. Right? So at here, if you observe here clearly, this is a crank BO and this is a velocity of B with respect to O. These two are perpendicular. So I am taking this here. So the same that we have to make a drag. Okay. So let this is velocity of B with respect to O. Okay. And that is the direction is this. Okay. Then what about the length of this? Okay. So for that I go for the value, I am using this value. So I got 4.173 meter per second, that I am taking a scale is 4 centimeters. That means this is 4, we can take any number guys. So it may be a 2 or 2.5 or 3, 3.75, whatever. So 4, 5, whatever. So whatever the velocity that I got at here, that I convert into centimeters because I can't draw this meter per second directly. Okay, this is the value it represented here in a diagram. Okay, by using a scale that is 4 centimeters. Clear? So next concept, I got this velocity of B with respect to O, right? Next, I need velocity. Okay, I am going to explain this velocity of A with respect to O. Okay, so if you see that here it is A is sliding or a fixed one, it is sliding over here in this direction. Whenever we have a sliding concept, there the sliding motion is must be a horizontal. If it is in vertical, that's enough. It move upwards or down. Incline. It must be horizontal way. The same horizontal that we will get a velocity. In a same horizontal that we will get a velocity. So that I am taking here it is in a horizontal. Horizontal, it will get a sliding motion. This line represents slider. That means piston velocity. Okay, we don't know the exact value of this. So that's why an approximate that I am taking here. Next, velocity of A with respect to B. So if you see while it is rotating in this way, that the AB is a connecting rod. So the connecting rod, that we will get the same perpendicular to this AB. Velocity of A with respect to B, it will get perpendicular to the AB, connecting rod AB in this direction, because while it is moving, it is coming downwards. Okay, so if you see it here, and this is a connecting rod in a space diagram, and this is a velocity diagram, that is nothing but velocity of A with respect to B. So here, so this is the same that I am taking here, that I have to draw it here. So this is the point B, and the intersection of those two, we will get A point, and this is B, and this is A, and this is A. They forget about the remaining lines. We can forget about the remaining line. So intersection of those two lines, we get a point, that the point is A. A is nothing but a slider. So this is velocity of A with respect to O, and this is velocity of A with respect to B. Hope you understand this concept. Here only thing that we did, velocity of B, velocity of A, we are finding here by using a graphical method, and this is the velocity of B with respect to O, and we are considering is a centimeters, right? So how to find this velocity of A with respect to B and velocity of A with respect to O? The same, the slider comes in a horizontal direction, so just I am taking a horizontal. This is the velocity, somewhere it will get. And this is a perpendicular to the connecting rod, so I am taking here a perpendicular. So though we have to make a drag as a perpendicular, so here is the same perpendicular we have to draw here. So while measuring this length, after measuring this length, for suppose it is L1, if it is L2, it is in centimeters, right? So the velocity that we are representing in a line, centimeters, we will get a centimeter. It may be you get a 2.5 centimeter, or it may be a 3 centimeter, or 2.75 centimeter, whatever the centimeter that we have to measure it, then we have to convert into meter per second. How to convert this? Because first of all, this get 75 centimeters. This is just an example, right? So if we get this is a 1.5 centimeter, right? Then we can convert into meter per second. How? That the 4 centimeter is 4.17 meter per second. So 2.7 centimeters, how many meter per second? So we will get it here. It is an approximate value, guys. So approximate value. So while we are drawing this, you will get exact value. So what's the velocity of A with respect to B is that we will get 3.4 meter per second, and here it is 4 meter per second. So like this we can calculate by using a graphical method. This is the way. First we have to draw space diagram, then after we have to find the velocity, then after here we have 3 steps. One is space diagram, next is velocity of B with respect to O, one of the link, that is a crank. Then we are, by using this, we are taking a scale and we are making a velocity diagram. From here, the unknown terms, we can find it by using a centimeter, and we can convert into meter per second. This is the way that we can make, for every problem, this is the only procedure. So it is easy to understand to get a velocities. Thank you.